Let's have a look. 1.6.
Oh, let's not go for the one.
Whoa, really? No way.
Oh.
2.4. All right, 2.4. Okay, an interesting design feature is to actually have the loading bar going right through the middle of certainly the compression member. Does it go through the tension member as well? Does it do both the compression and tension member? It's an unusual design. I haven't seen that before. That's really the main connection there.
We sort of thought the spreader bar would go in really tight, so we could kind of treated it a bit like a brace, and it's sort of not.
It's a massive hole you put through there, though. So the tension member itself.
Yeah, that could be.
It's got a massive hole in there.
It could be an issue.
Could be an issue. Could be an issue. There's lots to like about this design. You've got a bit of a lever arm up there, so there's a bit of rising going on. That washer may come out a little bit and start to pull out the wall if we get up to lows. I'm slightly worried about the massive hole through your tension member, really. You have got an extra little tiny rivet over there, which might carry something, but since you've got 4 rivets up the other end, it's a bit dodgy there. It's not bad. It should carry quite a bit, but not everything, because there's some mistakes. So shall I say 2.5? My prediction. 2.5, glasses on, everybody, glasses on.
Well done. All right.
Okay, that's all right. Lever arm on the washers.
Yeah.
Same as group 2, the second group 3 did, yeah.
Okay. Keep on. You can make it. There we go. Oh!
Okay, so you've got a zig and a zag. Nothing. Why nothing? Cheaper. It is indeed cheaper. I agree with you. That's a problem. There is no zag or reflection here. However, there is a subtlety here. There is a real nuance that if we were just hanging a big weight on here, we'd actually get a different result than if we were using a jack. For the reason is that my prediction is that there's essentially the effective length here sticking out is not braced, and therefore this can just move sideways. Yeah, and there's a big weight on it, it just moves sideways, the big weight would go with it, and it would then all collapse if we put 2.7 kilonewton weight on it. However, we've got a jack, so if that falls away, because the jack is attached to the floor, the jack's actually going to pull it backwards, which is a sort of second order effect. We didn't go through in class, but there is a chance that although this shouldn't work to carry a weight, it may actually work to hold the force carried by a jack. Okay? But it's a second order effect. So my prediction is you're not quite going to get away with it. That's my prediction, because you shouldn't. Alright, so my prediction is you shouldn't get away with this, so I'm going to be willing it to collapse at 2 points. I mean, every other calculus, the details look okay, that looks okay, everything else looks good. So my prediction is it is going to buckle in the middle at a slightly lower level than 2.7. So I'm going to 2.64 or something like that. I don't want you to get away with it.
Is that a river?
Something went.
Yeah. Oh my god.
What?
And it has gone in the way that we said it would go, with it going sideways, with these moving. They stay pretty much where they are, and it has moved this way. And somehow
That's taken the most out of everybody.
the ice mix balance, and this helping to pull it back. And you got away with it.
That's ridiculous.
Very good. Bolt there, is that enough?
Oh yeah, yeah, we attach the washers, I think so.
One bolt at the top's enough, is it, on each side? Has anyone else done it with one bolt so far? Has anyone passed the test with one bolt? Has anyone passed the test with just one bolt either side? Has everyone else did 2 bolts either side, didn't they? Did anyone do 1 bolt either side? Why did you all use 2 bolts either side? What, these people think you can do it with 1 bolt either side? Why? Have they done it wrong? Have they been too conservative? Or have you done it wrong?
We're just
Who's done it wrong here?
very close. Yeah. We're unique, sir.
You're unique. So that's very, very close. One of the things is you don't get a bit more prizing. You include the prizing factor? The factor 2 for prizing? No. You didn't include the factor. Do you remember the little seesaw that pulls the thing down and gives you a factor of 2 as opposed to a factor of 1?
Yeah.
And like, how many bolts did they use? 2, or did you use 1? Yeah, okay. Alright, so therefore you absolutely don't deserve to win, so I'm going to predict you're not going to win. They've done this clever thing as well of putting in no bracing. Again, I don't approve, but it does work. We've seen it, that it will fall to the side, but the jack will pull it back. So actually, if your effective length is L, that isn't going to fall over sideways, as it would do under a weight. Under a weight. Did you think this through, or did you just get away with it?
No, I definitely consider that. Design process.
Yeah. So you thought through, we don't actually need the bracing.
Yeah, definitely.
Because we
Because
get
of
the
the
jack.
jack, yeah.
We thought it through too, didn't we?
Yeah, of course. Okay. So the prediction
course,
is
our report's going to
those
talk all the
bolts
way,
should not
yeah.
hold at the top.
I mean, so with, what's your prediction for to buckle?
I'll just do the calculation. Let's go for 2.4.
Oh, that's pretty good.
And then a bolt will fly across the room, killing
Everyone.
anyone or anyone. 2.4 is what we do. And also they might rotate at the top as well, because it's all skew in. In fact, they are starting to rotate. In fact, there's one at the top, because you haven't got the two stops at rotation, whereas your bolts at the top, and so your tension members, you see them rotating up at the top. It's not fair. 2.4, yeah, that's it. 2.42.
Go.
Speed.
Be quick.
Let's go. Come on, jump. Show me more. Come on.
Slow and sure, that's how we did it. Yeah.
Looks bringing it home.
Well done, guys.
So is that 50 pounds for us? I think so.
That is a crime against structural engineering.